All right, and welcome back. We're still on 11.5, and this is video number 3, multiplying matrices. So you can only find the product of two matrices if their inner dimensions are the same. So what do I mean by their inner dimensions? So what I mean by is this dimension of the first one and this dimension of the second one must be the same. So the number of columns of row A must equal the number of rows of matrix B. Okay? So 2 by 3 is this matrix. This is going to be 2 by 3. So it's like this. And this matrix is 3 by 3. All right, and so the number of columns of this matrix must equal the number of rows of this matrix. Okay, so columns of A must equal rows of B. And when that happens, when you have that set up and you're able to do the multiplication, the final answer will have the dimensions of the outer values. So the final matrix will be 2 by 3 from these values. So this product is going to be 2 by 3. All right, now that we have that established, let's go ahead and see if we can figure out how to multiply these matrices. So the way we're going to do this is we're going to multiply each row of the first matrix by each column of the second matrix. Okay, so the first entry in this matrix is the first row multiplied by the first column. And the way we do that would be equal to, so that very first entry is A times F plus B times H. All right, the second entry in this matrix is going to be the first row by the second column. So that's going to be A times G plus B times J. All right, I'm going to run out of colors here. The second row of the product matrix is the second row of the first matrix times the first column of the second matrix. So that will be C times F plus D times H. And finally, I guess I'll use this highlighter. It's the second row of the first column times the second column of the second matrix. So that's equal to C times G plus D times J. And it's sort of a dink, dink, add, dink, dink, add movement. I'm doing a little finger motion here that you can't see. Whatever. All right, so let's do an example because this was very abstract and we'll see if we can get to this. All right, so we're going to compute the product A times B. We're in good shape here because the inner dimensions are both 2, and we know our end product is also going to be 2 since all the dimensions are 2. So let's write C equal to A times B. We're going to write out every single step. So we're going to take 1 times 5 plus 2 times 7. 1 times 5 plus 2 times 7. That's the first entry in our product matrix. Then we're going to take, for the second entry, 1 times 6. Let me switch colors actually. 1 times 6 plus 2 times 8. 1 times 6 plus 2 times 8. All right. Then we're going to take 3 times 5 plus 4 times 7. And finally, we're going to take 3 times 6 plus 4 times 8. 3 times 6 plus 4 times 8. And that is our matrix. Now we just need to simplify. This is going to be 5 plus 14, which is 19. This is going to be 6 plus 2 times 8 is 16, which is going to be 22. This is going to be 15 plus 28, which is 43. And this is going to be 18 plus 32, which is 50. As you can see, I may have even made a mistake here. I don't think I did. But as you can tell, it's really easy to make a computational error when you are computing matrix multiplication. It just happened. So let's actually, I'm going to go right now and let's go over to Desmos and we're going to double check our computations here. All right, let's check our computations. Let's put in our two matrices. A was a new matrix, and it was 1. I wonder if I can hit enter. Oh, no, that does not work. I wonder if I just hit enter to go to the next one. Let's clear all this. Sorry. Let's try again. All right, let's enter our matrix A. A, which is our new matrix, is 1, 2, 3, 4. And B, which is 5, 6, 7, 8. And now we just do A times B. 19, 22, 43, 50. Whew, we got that one right. It's a very good idea to check your answers with Desmos. It's very easy to make a mistake. All right, let's try another example of multiplying matrices. And let's find P, matrix P, which is the product of B times C. And we know we can multiply these guys because the inner dimensions are both 3. Before we even multiply, what is the dimensions of P going to be? Well, we look at the outer variables. It's going to be 2 by 2, right? The product will be 2 by 2 because we look at the outer dimensions. Let's give this a try. B times C equals. Well, we're going to take the first row of B times the first column of C. So in this case, it's going to be 3 times 4 plus 6 times negative 2 plus 4 times 5. Then it's going to be 3 times 10 plus 6 times 6 plus 4 times 9. Now we take the second row of B with the first column of C. Negative 8 times 4 plus 0 times 2 plus 12 times 5. 0 times negative 2, 12 times 5. And finally, negative 8 times 10. 0 times 6. 12 times 9. All right. Let's figure out what these are. Well, let's get it blue here. That's 12 plus negative 12, which is 0, plus 20. So that's going to be 20. That is 30. Minus, is that positive? Yeah, 36. And 36. That's 72 plus 30, which is 102. This is negative 32. This is 0, and this is 60. 60 minus 32 is 28. And finally, negative 80, 0, and 12 times 9 is 108, right? I believe so. And so 108 minus 80 is 28. There is our product, B times C. And of course, you can use Desmos to check. I feel like you guys can do that by now. I don't need to walk you through it. Let's try another multiplying matrices. So this is video 4, but I think I'm just going to keep going with video 3. And what I want you guys to do right now is I want you to calculate A times B, and then I want you to calculate B times A. Okay, that's what we're going to do. A times B versus B times A. So let's go ahead and give this a try. A times B equals, well, if we look A times B, the inner dimensions are 3 and the outer dimensions are 2. So this is going to be a 2 by 2 matrix, so let's give this one a try. Negative 1 times 5 is negative 5. 2 times negative 4 is negative 8. 3 times 2 is 6. That's the first entry. Negative 1 times negative 1 is 1. 0 times 2 is 0. 3 times 3 is 9. That's the second entry. 4 times 5 is 20. 0 times negative 4 is 0. 5 times 2 is 10. All right, last entry. Negative 1 times 4 is negative 4. 0 times 0 is 0. 3 times 5 is 15. So A times B equals negative 13 plus 6 is negative 7, 10, 30, and 11. So that's what we get when we multiply A times B. Let's go the other way and multiply B times A. All right, B times A would be equal to, let's rewrite it, 5, negative 4, 2, negative 1, 0, 3 times negative 1, 2, 3, 4, 0, 5. So this is 3 by 2 times 2 by 3. The interior dimensions are the same, so we can multiply these, but the result is not going to be a 2 by 2 matrix. It's going to be a 3 by 3 matrix. All right, let's give it a try. See if I can write it down here correctly. Negative 1 times 5 is negative 5. Negative 1 times 4 is negative 4. 5 times 2 is 10. 0 times 1 is 0. 5 times 3 is 15. Negative 1 times 5 is negative 5. All right, second row, first column. Negative 1 times negative 4 is 4. 0 times 4 is 0. Negative 4 times 2 is negative 8. And again, we have zeros. Negative 12. And again, zeros. I like the zeros. Finally, third row, first column. 2 times negative 1 is negative 2. 4 times 3 is 12. 2 times 2 is 4. 3 times 0 is 0. So that would be, back up. 4 plus 0. And then 6 plus 15. So our final answer is, we're going to have a much smaller matrix here. Negative 5 minus 4 is negative 9. 10. 10. 4, negative 8, negative 12. 10, 4, 21, if I did that correctly. So what can we say about multiplying matrices? So our first one, this is what we called L. This is B times A. And our first one was M. We called A times B. Those are not the same, right? So in matrix multiplication, we don't have the commutative property like we do in integer multiplication or real number multiplication or even polynomial multiplication. A times B is not necessarily B times A unless you have a very special matrix A. All right, so it's important which order you multiply. That's the end of this section, and see you next time.